During the medieval period, scientists in the Islamic world made many contributions to the field of astronomy. There are an estimated 10,000 astronomical manuscripts and close to 1,000 astronomical instruments preserved in libraries and museums that were created by Muslim scientists. But why was their work so important to the science of astronomy? Ancient Muslim scientists began updating methods for measuring and calculating the movement of heavenly bodies as early as the medieval period. Inheriting knowledge from ancient sources from Greece, Iran, and India, they continued to develop models of the universe and the movement of planets within it. The math required for astronomy was also advanced in large part by Islamic scholars. They developed the spherical trigonometry and algebra, two forms of math fundamental to precise calculations of the stars. One of the major reasons for Muslims' curiosity in stars was largely because of the specific requirements of Islam. It might be interesting to know that in Islam, it is important to accurately determine the time and direction of Mecca for daily prayers. Also, for example, correctly predicting sunrise and sunset for fasting during the month of Ramadan is necessary. Not only that, but they created a new calendrical system by refining scientific instruments that would help observation methods of the appearance of the moon, which was the start of the new lunar month in Islamic calendars. Developments in the science of astronomy were sped up during the 8th till 9th century when there was a huge promotion for translating scientific text in the Muslim world. Among the early books written about astronomy is Elements of Astronomy on the Celestial Motions, written by Al-Farghani around 833. This textbook provided a mostly non-mathematical presentation of Ptolemy's Almagest, updated with revised values from previous Islamic astronomers. Later on, it became the primary reference that European scholars used to study Ptolemaic astronomy. This book was largely responsible for the emergence of the Greek astronomical system of Ptolemy in the West. It circulated in several Latin editions and was widely studied in Europe between the 12th and 17th centuries. Through the 9th till 11th centuries, Islamic astronomers focused on criticizing and improving the geometrical models of Ptolemy. Al-Sufi, in his The Book of the Fixed Stars, combined Ptolemy's work of mapping constellations with Arabic astronomical traditions. Written around 964, the book contains extensive illustrations of constellations. Al-Sufi's illustrations were used for centuries afterward as canonical representations of constellations. In Europe, his works were translated and widely circulated. It's interesting to note that Al-Sufi was also the first astronomer to observe the Andromeda galaxy and the large Magellanic Cloud. These observations would have been made purely with the naked eye since the telescope hadn't yet been invented. Of course, he didn't know it was a galaxy at the time and marked it down as a cloud in his notes. Another interesting tidbit about ancient Muslim astronomers is that they were the first to build observatories, such as the Shamsiyya Observatory in Baghdad, built in 828. They also devised instruments and tools crucial for studying and measuring in astronomical researchers. One of the most well-known astronomical tools, the Astrolabe, was created by the ancient Greeks, but later perfected by Maryam Al-Astrulabi, a Syrian female scientist and astronomer who made astrolabes in the 10th century. Through such instruments and further calculations of the stars and their positions, many great topological and geographical discoveries were also made possible. The mathematical theorem named after prominent medieval astronomer Al-Tusi, called the Tusi couple, is considered by historians of astronomy a key element of Copernican heliocentric system. Building off of Al-Tusi's work, astronomers like Ibn Yunus and Ibn al-Shatir in the 14th century discovered major faults in Ptolemy's calculations, which changed the landscape of astronomy forever. The heliocentric model eventually proposed by Copernicus in the 16th century, which proved the Earth revolved around the Sun, was built on this body of work.